morning students, welcome back to your chemistry class. We had begun with a new chapter, polymers, and today we had to start with the classification. So yesterday I had told you how the polymers can be classified. Okay, so the first way of classification of the polymers could be on the basis of the source of origin. Okay, so first classification is of the polymers is on the basis of source. Okay, or we can also say of origin or origin. So on this basis, this polymer can be divided into three types. What were they? They could be natural polymers, then they could be semi-synthetic polymers, or they could also be synthetic polymers. This is what I had told you yesterday. So we are going to do all these classification in detail today. So let us begin with the natural polymers. The first one is your natural polymers. So they occur in nature and they originate from plants and or animals. Okay, they occur in nature and originate from plants and animals, because as the word suggests, natural. Okay, then example could be like your starch, a polymer of alpha D glucose. These are some of the examples of natural polymers. Okay, cellulose. Right, what is cellulose made up of? It is a repeat unit. Its repeat unit is beta D glucose. Its repeat unit is beta D glucose. Okay, for proteins it is polypeptides. Okay, formed by polymerization of amino acids. Then for rubber which is also your natural polymer, it is a polymer of isoprene. A polymer of isoprene, right? So when I say isoprene, I mean to say it is 2-methyl buta-1,3-diene. So isoprene is what? That is 2-methyl buta-1,3-diene. Clear? So these are also some of your natural polymers, and the monomers are these. That is cellulose. It is made up of the repeat unit of what? Beta D glucose protein polypeptides formed by the polymerization of amino acid. And rubber, the polymer of isoprene, or it is a polymer of 2-methyl buta-1,3-diene. Next, coming to the second one, that is the semi-synthetic polymers. So these are derived from naturally occurring polymers, right? By how? By chemical process. So as the word suggests, semi, that is, these are derived from the naturally occurring polymers by their some chemical process, right? So here examples could be like cellulose diacetate. It is used for making threads, right? And material like glasses, films, etc. Then even gun cotton as explosive, then vulcanized rubber for making tires. These are all semi-synthetic polymers. Okay, gun cotton as which is used as explosive, right? Even the vulcanized rubber which is used for making tires. So this was about semi-synthetic polymers. So natural polymers, they occur in nature and they originate from plants and animals, whereas semi-synthetic polymers, they are derived from naturally occurring polymers by some chemical process, and these are some examples. Next we come to, let's discuss the third kind, that is the synthetic polymers. Synthetic polymers. So these are the man-made polymers. Are man-made polymers. Okay. So example could be what? Like your polyethylene or polystyrene, or even your PVC or nylon or Tylon. All these are synthetic polymers. Okay, so our first kind is clear to all of you. On the basis of source or origin, they can be natural, semi-synthetic or synthetic polymers. Now we are going to move to another way of classifying polymers, that is on the basis of structure. So second way of classification of polymers could be on the basis of structure. Okay, so on the basis of structure, again they can be divided into three types. First one could be a linear polymers, then second one could be the branched polymers, and the third one could be the cross linked polymers. Okay, let's begin with the first kind, that is the linear polymers, right? They form the long straight chains, usually if you say the stack one over the other, and they form a well packed structure. Okay, so they form long straight chains, usually which stack over the other, and they form what? They form a well packed structure, right? So it could be like this. See, they are stacked over one another, right? This is called as a linear polymer. In the straight chain they are formed, right? Then due to close packing, they may even have high density, high tensile strength or high melting point, right? They could be like in the form of a chain also. Now since I'm using a thick nib, so maybe things cannot be so very clear to you, but I'll just try to make it clear. They are all stacked one over the other like this. See, this is the way they are stacked one over the other. So due to close packing, right, due to close packing, they have what, as I told you, high density, then they have high tensile strength, then they have even high melting point, right? So example could be your high density polyethenes. Example is your high density polyethenes. These are the example of your linear polymers, right? Now let's come to the second kind, that is the branched polymers. So let's see what are branched polymers. Okay, so as the word suggests, it consists of side chains attached to the main chain. Okay, they consist of side chains attached to the main chain, right? Then they are not packed in a compact form. Okay, they are not packed in a compact form, right? Then they have low density, they have low density, low tensile strength, but they have high volume. Low tensile strength but high volume. Okay, so let's see the figure. Like as I told you, they consist of side chain attached to the main chain. So this is the main chain, if suppose, then they even contain side chain. So side chain could be like this, in the form of a, what you say, the tree trunk. So it could be like this. So how can we show it? How can we show? I'll show it over here. Suppose this is the main branch. Okay, then it has some side branches. Can you see this? Then somewhat like this, the structure can be shown, right? So if you see over here, you see sometimes there is no link and therefore repulsion takes place over here. Not linked, therefore repulsion takes place. Is this clear? I hope through the structure this is very clear. Branched polymers, they can be branched like this. I've shown it to you over here. See, here they are attached, but here there is no linkage and therefore repulsion takes place from here, right? And therefore they show they are not packed in a compact form. They have low density, low tensile strength, but they have high volume. So example could be like your low density polythene. These are your low density polythene. The one that we used to earlier get, they were the branched polymers. Next we move to the cross-linked polymers. Coming to the third kind, that is the cross-linked polymers, right? Over here, if you see the structure, there's something like this. Right? So here the adjacent polymeric chains, they link up together through the side chains, forming three-dimensional polymers. And if you would like to see, I'll show it to you like this also. Okay, let me first draw the three chains and then they are hard, they are brittle, then here they are attached from here, okay, as I have shown you in between. Another one, 2, 3, 4, 5, just 2. They have high strength, okay, they have high strength, then they are brittle, they are hard. So what did I tell you over here? That the adjacent polymeric chains, they are linked together, okay, through side chains, right? And they forming a three-dimensional polymer. Is this clear? Then as I told you, they are hard, they are rigid and brittle also. They have high strength. So example could be like your bakelite. What are they? They are cross-linked polymers. Then even the formaldehyde resins, formaldehyde resins, etc. These are your cross-linked polymers. Okay, so just now we were doing what? On the basis of structure, we can classify the polymers into how many types? Linear, branched, or cross-linked. So in linear polymer, what did we study? That they form long straight chains, right? And usually they all stack one over the other and they form a well-packed structure. They had high density, high tensile strength and high melting point. Whereas the branched one, what did we study there? It consists of side chains that were attached to the main chain. They were not compact. They were not packed in the compact form, and because there was no link, therefore repulsion also took place. It was of low density, low tensile strength, but it had high volume, right? But over here in the cross-linked polymers, adjacent polymeric chains, they are linked together through the side chains and they form a three-dimensional polymer type of a substance. So they are hard, rigid, they are brittle, they have high strength, and so these were the difference between the polymers on the basis of their structure. I hope till here everything is clear. Okay, now let us classify the polymers on the basis of the repeating structure unit. Okay, on the basis of repeating structure unit. Then let us see, they are of two types. What are they? They are homopolymers and they are copolymers. This I had explained you yesterday. So a polymer formed from one type of monomer, it is called as a homopolymer. But if a polymer is formed from two or more different types of monomers, then it is called as a copolymer. Then in homopolymers, some examples could be your polythene or PVC, right? Whereas for your copolymers, as I had told you, we had styrene, butadiene rubber. That was your copolymer, right? Now coming to the fourth type, that is on the basis of mode of polymerization. Okay, you must be wondering I did not write anything about this because about both these homopolymers and copolymers I had discussed it in detail in your previous video. So if you want to check out about this, go through your first video. Now coming to on the basis of mode of polymerization, then large number of monomer molecules, they form the giant molecules through which two methods? They could be either through condensation, okay, or through addition. So this we are going to study just now. So let us first understand the addition reactions, addition process, right? So when large number of monomer molecules, they attach themselves to form a polymer chain, then the process is termed as addition process. What did I say? That when large number of monomer molecules, they attach themselves to form the polymer chain. Okay, the process is called what? Process is called addition process. So example could be the derivative of ethene, derivative of ethene. Here the repeating unit is the same. So process occurs through chain mechanism over here. Okay, so I hope the addition process is very clear. Next, let us come to condensation process. Condensation process. Okay, when series of condensation reaction, that is polymerization between monomers containing two or more functional groups, then it involves loss of small molecules such as water or ammonia or alcohol, right? This process is termed as condensation process or condensation polymers. So when series of condensation reaction takes place, that is polymerization between monomers containing two or more functional groups. It involves loss of small molecules such as water, ammonia, alcohol, etc. Right? So this process is termed as condensation process. Let us see it through the reaction over here. So I'm writing over here the hexamethylene diamine, N times NH2 CH2 whole thrice NH2. What is this? This is your hexamethylene diamine. Okay, when it combines with adipic acid, that is N times H OOC CH2 for COOH. What is this? This is your adipic acid. Okay, so what do we get? We get, I'm writing down over here, nylon 66. That is, how do we write down nylon 66? I'm opening the whole thing and writing it down over here. Okay, so this is NHCH2 6 NHC double bond O CH2 4 times C double bond O N times. Okay, what is this called as? This is called as nylon 66. I hope on the basis of mode of polymerization, the two processes very clear to you. The addition process is when large number of monomer molecules, they attach themselves and they form a polymer chain. But what is condensation process? When series of condensation reaction takes place, that is polymerization between monomers containing two or more functional group. And what it happens over here? It involves a loss of small molecules like water, ammonia or alcohol. Then this process of forming a polymer, it is called as condensation process. Okay, so this was the classification on the basis of mode of polymerization. So the fifth type of classification could be on the basis of molecular forces, right? Then here How are they classified? They are classified into 4 types. What were they? Elastomers, then fibers, then thermoplastics, and thermosetting. Okay, so let us come to the first one, that is elastomers. Now, intermolecular forces of attraction is very low over here. That means they are more stretchable. They get coiled chains. They open up on stretching. They release the force. Cross-linked chains are formed over here. Such kind of polymers are elastomers, where elasticity could be found in them. So for example, over here it is your vulcanized rubber. Okay, so intermolecular forces of attraction is very low over here. Okay, therefore they are stretchable. They even form coiled chains, right, and open on stretching. Okay, they release the force and cross linked chains are formed. Okay, so these are called as elastomers. Example, as I told you, it was your vulcanized rubber. Next, let us talk about fibers. What do we know about fibers? They have strong intermolecular forces, okay? And they have no elasticity. What did I say? They have strong intermolecular forces and no elasticity. Fine. These are termed as fibers, and the example could be the nylon, if you have seen, or terylene is also your fiber, or polyesters, they are also fibers, etc. Coming to the third kind, that is thermoplastics. What are thermoplastics? Fibers we did, elastomers we did. Now let's talk about thermoplastics. They where the force of attraction is intermediate to the elastomers and fibers. Then they are termed as thermoplastics. When they are heated, they become soft. When cooled, they can be used as they become hard. Okay, so example could be your Teflon or PVC. So let me write it down over here for you, where forces of attraction is intermediate to your elastomers and fibers. Okay, between these two. But what, like elastomers, over here the intermolecular force of attraction is very low, whereas in fibers the forces of attraction is very strong. So intermediate to both these elastomers and fibers, we get thermoplastics. Okay, then when they are heated, they become soft, and when they are cooled, they become hard, and then they can be used. So when heated they become soft, and when cooled they can be used as they become hard. Okay, so let's take the example could be like your PVC, or it could be even Teflon. These are termed as thermoplastics. And we come to the last type, that is thermosetting. The fourth kind, thermosetting. Over here, the force of attraction is strong. They show close network structure, right? So when they are heated, they cannot be molded to another form. They cannot be reused. Fine. So they are termed as thermosetting. What did I say over here? The force of attraction between the molecules of these kind of polymers is strong, right? They show close network structure. If heated, they cannot be molded to another form, right? In other words, we can say they cannot be reused. Cannot be reused. Clear? Example, what it could be, like bakelite, or even it could be melamine, right? So with this, I wind up today's video. I'll come up with more classification tomorrow. Till then, thank you.